Hi there, I'm Clyde Troutman, Engineering Manager with 3Say Technologies. I'm here today to introduce you to the 3Say Lens Forming Station, or LFS. The LFS is a lens forming tool based on a ring of fire technology used for performing or creating a ball lens on the end of an optical fiber. It's compatible with fibers from 125 microns up to 600 microns. Right now I'll give you a quick demonstration on how to use the machine. If you look inside, we have a rotator and a fiber holder platform. The fiber at this point has been prepared. In advance, we prepare the fiber by removing the coating, cleaning the fiber, and then cleaving the fiber to get a nice clean end face. We start with a nice flat before we create the ball. We load the fiber into the fiber holder platform inside the machine just by rocking into place here. It can be set up so that the fiber actually appears on the screen. And at this point, we just simply close the door. And we can actually see from this point, we have a very simple operator. This is focused on a production-based environment where any operator can come up and run the machine quite quickly. You select a recipe. After you have your recipe selected, you simply hit the run sequence, and the program will step through a pre-programmed sequence. For this, we have 125 micron fiber. We're actually going to create a 200 micron ball lens on the end. As you can see, the fiber is fed up into the ring of fire, which heats the fiber, creating the ball. And the process will continue as we approach the ball diameter, in this case 200 microns. Here we are plotting out the actual measurement of the ball lens as we go, and you can see on the chart where we started at 125 microns and we're slowly increasing till we hit the 200 micron limit. When the machine detects that we have matched our 200 micron limit, it'll do a test. It looks at the fiber at 0 degrees and rotates and looks at the fiber again at 180 degrees, at 90 degrees, and we'll measure the fiber twice to make sure it matches all the criteria. We're looking for the roundness of the lens, the offset of the lens to make sure that the lens is centered on the fiber. We're also doing a critical measurement called our EAR, which is our effective area radius. That's a tool that measures the center of the lens to measure the radius at the portion of the lens where the light is exiting the fiber. That process can also be used as a control to determine the lens shape itself rather than as a secondary measurement. That's an option that can be toggled in the program. From here, we're also measuring fiber outer diameter and the effective area roundness. And all this information is factory set. You can set this as an engineer so that your operator, all they need to do is get a pass-fail criteria. When the test is done, again, I said we look at it straight and we rotate 90 degrees to look at it for the second angle, in which case anything that would be bad or falls out of the limits would actually be identified here in red, and it would tell the operator that this is a good or bad lens. In this case, our ball lens meets all of our criteria. It gives us the option to provide any notes and hit save, at which point we're saving an image of the fiber, and we're actually saving all the data that we used, both of the recipe to create the fiber and in the final test data. Thank you for your time. For additional information, please visit us at our website at www.3say.com.